All right, this is Unit 4. We are looking at Section 2 on page 2. The information on the periodic table. So during this video, I would recommend having a periodic table handy that you could look at. You should have one in your binder. If not, you can find one on Google Image Search. They're out there. There's a lot of different ones you can find. Take a look at the periodic table. Every element has a unique place on the periodic table. Each element has a box, and it contains information about its identity and its characteristics. At minimum, you'll find 3 pieces of information: the atomic symbol, the atomic number, and the atomic mass. Any periodic table should have these 3 pieces of information at minimum for any given element. So first off, the atomic symbol is a 1 or 2 letter abbreviation that represents the element. Some of these make sense. O represents oxygen, C is carbon, N is nitrogen, Mg is magnesium. Other atomic symbols might make less sense. For example, the symbol for sodium, if you're looking at your periodic table, it's on the left side. Capital N, lowercase a. This is one that's worth remembering. Don't be the student who tells me on the second semester final that the atomic symbol for sodium is S. S is sulfur, Na is sodium. How about mercury? Mercury is towards the bottom, middle of the periodic table. Why is it Hg? Why does Pb represent lead? These don't really make sense, at least not to us. The answer comes down to different languages that people speak. Many of these elements, these chemicals, were discovered by people who just did not speak English. A lot of names come from Latin or Greek. These are 2 languages that have been around for a very long time. Latin, we're talking about just over 2,000 years. Greek, we're talking about well over 2,000 years. These are old languages. They've been in use for a long time. Some elements have been known for thousands of years. For instance, lead and mercury. They're named for their Greek names. And this was well before the modern dominance of the English language. This really has only happened on a global scale since the end of World War II. The language of Latin was really the language of science until this. So until about 70 years ago, or even more recently in some circles, if you were a scientist, you had better speak Latin, or at least be able to read and write Latin, because it was the language of science, it was the language of medicine. English was not thought very highly of until relatively recent times. The next piece of information is the atomic number. The atomic number represents the number of protons in the nucleus. The number of protons determines the identity of the element. Atomic number is always a whole number. Fractions of a proton do not exist. If you're looking at your periodic table, the atomic number is generally towards the top, usually towards the right corner of your individual boxes. And like I said, it's always a whole number. Hydrogen's atomic number is 1. Hydrogen has 1 proton. The atomic number of neon is 10. Neon has 10 protons. The atomic number of uranium is 92. It has 92 protons. We could go through, countless numbers of these. I'll just highlight a few. Element, its atomic symbol, its atomic number, and let's write it out. The atomic number and the number of protons. So these 4 things. So for instance, looking at your periodic table, the element carbon. Carbon is at the top, just to the right of the middle. Its atomic symbol is C. That one makes sense. Its atomic number is 6. That means that its nucleus has 6 protons. The next one, let's use aluminum. Aluminum is very close to carbon. It's towards the top. It's just to the right of the middle. Its atomic symbol is Al, capital A, lowercase l. The first letter is always capitalized. If there's a second letter, it's always lowercase. Its atomic number is 13, which means it has 13 protons. Krypton. Krypton is at the far right of the periodic table, about halfway down. The atomic symbol is Kr. Now this is krypton, not kryptonite, 2 very different things. Krypton is a gas. Kryptonite is a fictional crystal. So you find it, the atomic symbol is Kr, and the atomic number 36. This means that krypton has 36 protons in its nucleus. Let's look at one more, gold. Gold can be difficult to find on the periodic table, especially if you're using the classroom model, the classroom periodic table, which does not have the names on the wall. So you've got a lot of different elements that start with the letter G, but none of them are gold. So if you're looking at the periodic table in your binder, it is left to right, just about in the middle, and it's towards the bottom of the main periodic table. It's a transition metal. Au comes from its Greek and Latin names. Aurea, if you know Spanish, usually something like this, oro, Au. Its atomic number, 79, which tells us that its nucleus has 79 protons. Next up is the mass number. The mass number is the number of protons and neutrons in an individual atom. If we had one atom that we could hold in our hand and look at it, the mass number is the number of protons and neutrons in that individual atom. The mass number is always a whole number. There's a number of protons and the number of neutrons. Those are both whole numbers. You have whole protons, whole neutrons. There's never fractions. So it's always a whole number. It's also not included on the periodic table because one particular element could have different size nuclei. For instance, carbon. Some carbons have a mass number of 12, some have a mass number of 13, some have a mass number of 14. So mass number is not included. Atoms of the same element can contain different numbers of neutrons, and these are called isotopes. So we're going to look at two different elements that have several isotopes. So for this one, we're going to look at carbon. Carbon has 3 isotopes. So the first one is carbon-12. There's carbon-13. And there's carbon-14. So we want to look at mass number, number of protons, and number of neutrons. So when we're looking at these, carbon-12, carbon-13, carbon-14, the number is telling us the mass number of that isotope. So the mass number of carbon-12 is 12. If you're looking at your periodic table, find carbon. Carbon has an atomic number of 6, which tells us that it has 6 protons. If there are 12 subatomic particles in the nucleus, and 6 of them are protons, then 12 minus 6 tells us the other 6 are neutrons. For carbon-13, the mass number is 13. How many protons does carbon-13 have? Look at your periodic table. The atomic number is 6. Number of neutrons can change. This is a different isotope. So mass number is 13. There are 6 protons. 13 minus 6 tells me that this isotope has 7 neutrons. And then carbon-14, your radiocarbon dating. This is the one that they use to determine the age of things like fossils, anything they dig up archaeologically. Carbon-14 has a mass number of 14. Like all other carbons, it has 6 protons. 14 minus 6 tells me that it has 8 neutrons. Over here, we're going to do the same type of table. So we're going to look at mass number, number of protons, and number of neutrons. In this one, we're going to talk about hydrogen. And you're going to see it written differently. H11. For this one, it gives us the mass number. It also gives us the atomic number. As we go on, we'll see which one's which. But in this case, the mass number and the atomic number are the same. The mass number is 1. If you look at your periodic table, hydrogen is at the top left corner. Its atomic number is 1, which means it has 1 proton. If the mass number is 1, and there's only 1 proton, then that means it has no neutrons. 1 minus 1, 0 neutrons. A single hydrogen atom, hydrogen 1, is really just a proton. The next isotope, hydrogen 2. So the mass number is the top number, and the bottom number is the atomic number. So the atomic number doesn't change. It was always 1, which means 1 proton. This hydrogen has 1 neutron. Hydrogen 3, or hydrogen 3, has a mass number of 3, still 1 proton, and it has 2 neutrons. So most of all the hydrogen in the world is hydrogen 1. It's pretty typical. It's the one that you would find in water, you find it in your bodies, you find it in food. It's very common. Hydrogen 2 is less common, and normally we have to get it from something like a large lake. Like you can pull hydrogen 2 out of Lake Erie from the water, and other freshwater bodies too. But for every 10,000 gallons that they filter, they only come up with maybe a few milliliters of this hydrogen 2. It's not very common. And there's hydrogen 3, which is even less common, but it's very interesting because hydrogen 3 glows in the dark. It glows all the time because it's radioactive. And you can find compasses out there that are radioactive, that glow in the dark, and they're filled with hydrogen 3.